Okay, let's see. Eric and I were chatting yesterday, so this is kind of a new development. Just-in-time presentation production. Actually, just-in-time engineering in this particular case. So what was it, about 4 years ago that Christian Hogsberg put together our new DRI extension called DRI2. It was supposed to solve, oh, you're here today. It's supposed to solve all the problems of DRI1, and it solved a lot of them. And introduced a lot of new problems, and we thought we'd come up with some, do some on-the-fly development here while a bunch of people who understood this stuff were sitting around and kind of vet some ideas that we were thinking about yesterday. So the problems that DRI2 were solving were obvious. We had the shared memory disaster where the X server and the DRI1 applications would share information about the DRI buffers in a shared memory, in a global shared object, which was a disaster. Allocation was kind of a mess. The applications that do most of the memory management and kind of pretend to tell the X server. DRI2 solved a lot of these problems. The X server took over all the allocation of buffers, which fixed the GLX, which made it possible to do GLX, the GLX buffer sharing semantics, where the GLX applications could actually, you could actually have multiple applications sharing the same back buffer, depth buffer, stencil buffer. Fortunately, that turns out that's been broken. It's awesome. So we wanted to come up with some ideas. We wanted to first list some problems that we had with DRI2 and then list some potential solutions. So the biggest problem we have right now with DRI2 is that when the window resizes, so when your application window resizes, the X server needs to reallocate the back buffer so that you get a back buffer matching the window size. And then it needs to communicate this reallocation to the application. So the application used to be drawing to the old back buffer, and it now needs to draw to a new back buffer because it's a new size. And so we have this horrible kludge all through XLib right now, which the XCV backend can't support, where you get this event being sent from the application, from the X server to the application, telling it that its back buffer is now different. Please draw to the new one. And if the application doesn't get this event in time, it sends a bunch of rendering to the old back buffer, and it's a synchronization disaster, right?
Yeah, that's right. And there's this nasty hack present in XLib that allows the GL library to tell XLib, when this event comes in, please tell me about the event, and I'll tell you whether to pass it on to the application or not. So GL is sneaking into your application's event stream and filtering out some stuff that only it wants to see. And this is XCB's is opposed to this idea. They don't want to actually have these sort of magic callbacks for filtering X from the application.
It's hard to say that that's an unreasonable position, but I mean, unfortunately, DRI2 requires it because we need to be able to switch in mid-rendering between two buffers. The way that this works today is that most applications, most GL applications, happen to render frames on a regular basis. And so the fact that one frame is kind of scrambled when in the middle of the frame the window got resized and half your rendering went to one buffer and half your rendering goes to another buffer, you see a glitch on the screen and then the next frame is rendered and it's like, oh, what was that? So it doesn't bother you too much, but you know, we can probably do better than that. The other thing is that right now, in order to allocate a buffer, in order to do a swap buffers or any of those operations, you need to tell the X server that you're doing the swap buffers, and the X server sends back to the application, oh, and your new frame, please render to this new buffer. That's bad in a couple of ways. The first way is that it's a round trip. Oh my God, we hate those, right? And the second is that the X server makes no promises about what the contents of that buffer are. Right, you get a back buffer and it's like, well, I don't know, there's some stuff maybe in it. You might want to clear it before you draw to it because it might not be cleared already. Or it might have, you know, some other application's contents in it that you don't want to show in your application. Is that?
Yeah, I think we only return buffers that have been... Yeah, no, they could have pretty random garbage in them. That's right.
I didn't think there was any restriction at all. Unfortunately, the GLX protocol definition says that if two GL applications draw to the same window, they get the same back buffer. And they're supposed to get the same depth buffer and stencil buffer and
aux buffers.
But in the long tradition of how X deprecates bad functionality, it turns out this has been broken for a while. Has anybody noticed? Nobody noticed. So this is the official mechanism of the X window system for deprecating stuff which is dead. You break it accidentally, well, nominally accidentally. Wait a couple years, ask if anybody's noticed, and when nobody says anything, you say, oh, well, apparently nobody's using that, we can go change it now. So DRI2 was all predicated on the notion that you needed to do X server-side allocation so that you could actually implement GLX semantics correctly. A noble goal. What? A noble goal. However, we've discovered that it's actually been broken for a couple of years, and so maybe we don't need to do that after all. And so what if we revisit the notion of where the buffers are allocated and move the allocation from the X server back to the application where God intended it to be? What do we get from that? Well, we get a couple of things. Now the application is entirely in charge of how big to make the buffer. Does GL provide information about how big the buffer might want to be in one of its APIs?
The GL viewport call for what rectangle should I draw to?
Could this be used to set the size of the output area, and maybe the application could be in charge of making sure that that matched the window size if it cared? What?
The stride is a purely driver internal question. So when I allocate my buffer, I choose a stride. There's nothing at the API level or at a potential swap buffers call that would need to know that, really.
You just need to make sure it's the right size. And then it's the GL library's responsibility to make sure that that can actually draw to that, right? So there's no actual. So the only thing we needed from the X server was the size. And it turns out that the application usually provides that size to us in the form of the viewport call. So we have the information about what size to make it on the application side. And not only that, but that size is synchronized with the application's notion of its window size. So when it does things like scaling window contents, it's scaling to that viewport, right? It's not scaling to the actual window size. It scales to the window size it saw the last time it got a resize notify. So we're going to actually get the correct. We're not going to get clipped contents, randomly clipped contents to the wrong size. Another thing that we can do with this is, now that the application is in charge of allocating its own buffers to draw to, the application is now responsible for lifetime management, and the application is responsible for recycling the buffers.
Sorry, the GL library.
The GL library, yeah. Application, it's all an application to me. So when the application wants to get an old buffer and draw some new content to it, like a compositing manager, where you want to just update a tiny little portion of the window because only a tiny little portion is changing. Now I can get an old stale buffer that was used 4 frames ago, and the GL library can say, oh, by the way, this contains the contents of your application from 4 frames ago. That might be useful information to you as a compositing manager.
Yeah, right now, GNOME Shell, for example, doesn't do page flipping because it always wants to do a sub-region update to the screen, and if it calls swap buffers, which would enable page flipping, which is the highest performance way of changing the screen, it would have to redraw the entire screen because it doesn't know what's in your back buffer.
So by managing the buffers on the application side, GNOME Shell is going to be able to say, oh, I know this buffer. I've seen it before. It's missing the following three letters the user typed in. Right? So we get a huge performance benefit there, and more applications should be able to start using swap buffers. Last night we thought of another cool thing that we could do with this. Another cool thing is that we can have the X server, when the X server is done using a buffer, instead of dereferencing it and throwing it away, we can have the X server mark this buffer as purgeable. So you send a back buffer to the X server copies the contents onto the screen. The X server is done with this back buffer now. The application doesn't want this contents anymore. The X server can mark this buffer as purgeable so it can get discarded eventually. And then when the application comes back to reuse that buffer, it says, oh yeah, I want to reuse that buffer. If there hasn't been any memory pressure in the system, that buffer is still around. If there was memory pressure in the system, that buffer has been discarded and the application says, oh, I don't get an old buffer, I have to repaint everything. That's exactly what you want, though, because you want that buffer. For instance, in a 2D application, which is only updating periodically, like every time you type a letter, if your window there, your nicely double buffered X term window, has a back buffer from an hour ago, and your system starts to run low on memory, you'd really like that buffer to go away. And so this is going to allow us to hand the buffer to the X server. The X server is going to mark the buffer as purgeable. And then if there's memory pressure, that buffer will go away eventually. And so our back buffer is going to disappear. We'll save a bunch of memory. Right?
Yeah.
The other thing that's changed since DRI2 came into existence is that we have this kernel infrastructure called DMA buffers. Right? DMA buff?
DMA buff.
DMA buff. It's a shortened form of DMA buffers, I'm assured.
All one word, though.
But all one word?
I think so.
Okay. DMA buff is a way of passing objects, passing chunks of memory between drivers, right? We desperately want to pass a chunk of memory from an application to the X server, but would really like to be, you know, kind of private about it. We don't want to tell the world about these contents. We want to tell the X server about these contents. So instead of using gem F-link handle and passing that over the wire, which is just an arbitrary 32-bit integer which can be, you know, discovered, as we saw from the security presentation a few minutes ago. What if we pass a DMA buff file descriptor through the Unix domain socket? Yeah. Does that sound like a good idea? Yeah. So that all of a sudden, my transfer of information from the application to the X server is private between me and the X server and does not involve other applications anymore. What? Question? Oh.
No, I think that will also make the part work better when you have a graphics card that's rendering the frame and they have another card that's presenting the frame. In the case of Optimus, for example.
Yep.
And then you wouldn't just be limited to the graphics card. You might even have some other device doing it.
Oh, that's a good idea. Yeah, and so when you're doing when you have your Optimus environment and you're rendering with the accelerated off-screen GPU, and all you have is a scan-out engine in the X server, then using a DMA buffer means that you can actually pass the information from the GPU to the display engine without ever having to go through this artificial gem handle stuff. Oh, excellent thought. Okay, I like that. I like that idea. As I said, Eric and I just started talking about this yesterday. Last night, yeah. So we're thinking about it. So the thing that it completely destroys is the ability for GLX to share back buffers among applications. Question? Oh, use the microphone.
Sorry. I mean, one answer to that is just say only support EGL.
Yeah, we could only support EGL, but that doesn't help existing applications a lot. Mm-hmm. And I really don't want to support two mechanisms for doing buffer allocation, right? We have enough trouble getting one tested and working, so I'd really like to get rid of the other one and use the same mechanism for both. Right now we use DRI2 for both EGL and GLX.
Yeah, okay.
And I'd like to be able to just shift over to a different mechanism and say, I'm sorry, GLX applications. The IDR back there is going to cry at us.
That's my talk.
What, not doing GLX officially? Oh, kill GLX entirely. Okay. Oh, well, yeah, yeah. Can we make GLX work like EGL? Would that be okay in the intermediate time? Okay.
The other thing I was going to say is, what about YUV buffers?
YUV buffers. Right now we have the ability to pass YUV data in the XV extension using the shim stuff.
Right.
Yeah.
But that's, yeah.
There's no particular reason this couldn't be. We couldn't pass YUV buffers as DMA buff as well. Because one of the nice things about this is that using DMA buff instead of using gem handles is that you can get that buffer from any driver. So if you have a separate video decoder, as long as you're given a DMA buff handle, you can hand that to the X server.
Right. But in the protocol, you probably want to think about potentially having multiple file descriptors for one buffer if you have planar data and right. If you have multiple planes.
You don't hook all those up into one giant DMA buff?
They would be, if they're separate buffers, they'd be separate DMA buffs. So the DMA buff, sorry, the DMA buffs would be one-to-one with the gem objects.
That's so just wrong.
Well, it's meant to be closer at the gem level rather than at the KMS frame buffer level.
Well, whatever. One of the so this is we're specifically thinking in the notion right now of targeting just the GL stuff and getting that to work. Obviously, extending the DRI3 stuff to support additional formats would be possible. Probably a good idea.
Yeah, I mean, as long as you're, I mean, I played around a little bit with extending DRI2 for YUV and video.
Yep.
Which it gives nice results in getting rid of an extra blit.
Yep.
But if you're going to go ahead and define a new protocol, we might as well leave space
Sounds like a good idea.
for that.
Yep. And I'd like the notion of using the DMA buff handles on the wire instead of this arbitrary driver-defined integer. It gives us a lot better semantic coverage. What? Yeah. Yeah, which is nice. Okay. More questions and comments? As I said, this is new. I'd really like to hear about other feedback. The notion about making sure that we support multiple file descriptors is a good idea. Jerome, you have some?
What about the swap buffer?
So this is how you support swap buffer. You hand the DMA buff over the wire, and say this is my and say swap to this. Essentially, that's what the swap buffers request.
So it would need to have all of the VBlank information that our current swap buffers has. Basically, all of the existing parts of our swap buffers protocol, except replace the attachment point in the protocol with a DMA buff name.
So it's not a huge change to the DRI2 except for how the allocation is done and the name of the object. So you take the existing DRI2 protocol and just replace gem or attachment point or whatever we call it with a DMA buff FD.
Sounds good.
Sounds good. As long as somebody else does the work, he's all for it. Any other questions or comments? One back here.
Do I get that right that that makes it also possible for an application to have more than one back buffer? Like, for example, in VDPower or video decoding applications, we sometimes got not two buffers switching between them, but for example 6 or something like that.
Well, for instance, in 3D, you desperately want to do triple buffering, right? This should let us do triple buffering in 3D. In media, you want to be able to save that ancient buffer as a reference frame. Yes, obviously. Yep. So the only thing you're passing to the X server now is this is the buffer I wish to display, please. Right? The X server no longer has a notion of a back buffer. You're basically saying, here's new contents for my window. A lot like some other Windows systems do.
How does this affect GLX indirect at all? It
has no relationship with GLX indirect.
Well, right. I mean, the same things that Okay.
Right. So in GLX indirect, GLX indirect would now allocate its own back buffer in the GL library in the X server nominally, and it would use the same APIs inside the X server to pass that buffer, possibly even as a DMA buff handle, around inside the X server.
Yeah, that's what I was wondering.
It doesn't matter. That's all inside the X server implementation. And if indirect rendering, so indirect rendering for me has been broken for the last year. Every indirect application I've run just seg faults. So apparently nobody else noticed, but I did. I had an application that was using the GTK GL binding, which stupidly provided a Boolean to the application. Do you want indirect rendering or not? And I had an application that said, sure, that sounds awesome. Yeah, if anybody can explain to me why the GTK people thought it was important to expose this to applications. Oh. Yeah, my application author got it wrong. Who would have guessed? True, false, pick one. Oh, it seems to work with either. No. This was forcing indirect rendering. Yeah. And did you have one more comment?
So what happens when you do a resize? So let's say the application doesn't send a new buffer, like for a minute or so.
Yep.
For whatever reason. What VXF do?
So at this point, if you're going to do if the window is a different size than the buffer coming in, then you're just going to you're going to do a regular blit, right? You're going to blit from the source to the destination of the destination size. So you're going to get whatever clipped result you would get in that case.
Okay.
It's just going to clip.
So does that mean the XR will have to allocate some kind of temporary buffer depending on?
Oh, it wouldn't be able to do a swap in that case. That's true. It would have to do the blit. Yeah.
And also do some kind of allocation.
No. It's already got a new front buffer, right? The window has a front buffer. But instead of swapping between the back buffer and the front buffer, it would have to blit from the new back buffer to the front buffer.
If you get the XR doesn't have the new buffer because you only have the old buffer.
No. The X server always has a buffer for the window, right? If the window's been resized under composite extension, there is a buffer for the window.
Okay. Good.
Right. And in fact, the only time you get to use swap is if the buffer coming from the application is exactly the same size as the window buffer. So you would have to have the decorations in both or the decorations in neither. So that the existing swapping semantics are still required. If you're full screen, you'll be able to swap as long as the buffer is allocated for presentation is the right size and geometry and everything else. So we have the same exact swap requirements we have today. It just may be that the application is a couple of frames behind in getting the resize information, and so you're not going to get to do the swap optimization in those cases. But eventually the application will see that resize event, it will tell the GL library the new viewport size, and we'll start allocating buffers that are aligned with the new window size, and then you start swapping again. So as you're resizing, you're going to get some copying, and then eventually when you stop resizing, you'll start swapping again. Is that enough? You have one more question back here? And we're kind of winding down now, so we'll stop annoying you and let you go back to your regularly scheduled program.
Let's suppose we have an application who wants to do triple buffered rendering.
Mm-hmm.
So it does swaps in between the frames. How does the application know when it's allowed to render to a back buffer?
So the choice of triple buffering or not is something that's hidden from the application. It's internal to the GL, right? That's the way that things are today, is that just you get some back buffer and hopefully it's ready to be used. So the GL library, in our case, would choose to allocate 3 buffers and rotate between them as the X server tells it that your old buffers are ready to be reused.
And again, we can tell that the buffer is ready to be used because the X server has marked it as purgeable. Right, so when we go to pick a new back buffer, we're going to go list through all the buffers that we currently have and pick the one that's marked purgeable.
Yeah, so when you send the frame actually to the display, then you mark it purgeable.
Right. No, when it's no longer being used. So if we're scanning out from it, it's not marked purgeable. But when you swap to the other one, then that one's marked purgeable. So in a triple buffering case, if you have 2 buffers, 2 back buffers and 1 front buffer, then if you're going at faster than the frame rate, one of them is going to be marked purgeable because it's not been put. Oh, that's not going to work. We need a separate flag.
Yeah, I think I want the reply on the swap buffers saying, look, I expect that you're going to ask me for a buffer real soon, so here's some buffers that are usable right now.
Yeah, but in the case of triple buffering, you actually want to steal the buffer that it might have been about to display. Yeah. Yeah, exactly. This is going to take some thought.
Yeah, I think we just need to expose a control to the app of if you're going way too fast, do you stall on that third swap, or the frame that's pending that hasn't been displayed yet, do you just forget that one because you're trying to do a game benchmark at 500 frames a second and you're not going to see that crap anyway?
Yeah.
Right? I mean, there are 2 possible behaviors, and there's times when you could want one or the other. So I think we just have to give a control so that they can pick. And
then we need to figure out some way to make sure that the application is going to get a buffer that is not going to get swapped to on the screen. Yep. Okay. I think this is doable. Christian.
So, you can actually use GL viewport for resizing. I did this for DRI2, and it was one of the big mistakes in the interface, and we had to go back and add the invalidate event to make things work right.
Why?
Well, the problem is that GL viewport is not about the buffer size. It's the viewport that you're going to render to, and it can be any kind of sub-rectangle of the buffer. So you could just say, okay, let's use the biggest viewport we've ever seen and use it as the window size. But the problem is if you do that, you won't be able to ever shrink your back buffer. You'll always have to render to the biggest size you've ever seen.
Until you swap. Right? After a swap, the size of my back buffer is undefined, so I can just use my current viewport size after that. So I'm choosing a new buffer after I've swapped.
Right, yeah, okay.
Yeah, so you're going to choose, you know, probably use the largest viewport size that you saw for your last frame or something, right?
Why not making the reply of the swap buffer containing the width and height of what the buffer is supposed to be in size?
So one of the things we were trying to get at was avoiding blocking on the reply for the swap buffers, which technically does limit your frame rate at the highest end of frame rates, which is ridiculous, but people keep measuring it. But also, you know, so when the frame gets resized after my swap buffers, you know, midway through my rendering, this window got resized and the application is like, oh, I need to go redraw at this new size. It passes us a GL viewport of a bigger size than what we had before. We have to resize to that.
Yes.
So I think that separate little viewports that are the, you know, the X, Y, and Z parallel views and then the one perspective view. So you never see a viewport that the window, you see chunks of it.
Right. So what I'm thinking is that the size of my back buffer is, you know, the size of all of the viewports that I've seen since my
so the extent.
swap buffers. Yeah, it's the extent of it. And I have to actually do the copying, unlike right now when I just pitch the stuff on the X server, which is kind of a crappy move because how do you know that the client's actually going to repaint everything based on a configure notify having happened? Right. You don't.
So yeah, I think the size stuff is going to take some more pondering.
Yeah, particularly the choice of at the point of my swap buffers, what size do I want to allocate initially if I haven't seen a new GL viewport?
Yep.
So can I, for Wayland, because we have the same problem there. I mean, what you described is basically how we manage buffers in Wayland, except we push it directly to the compositor instead of to the X server and then the compositor. But what we do is when you want to, the application basically controls the size of the buffer. So
yeah, of course.
I don't get to change X applications though.
Right, but I'm just, as I said, I'm just describing how it works right now. And we could make an extension so that applications going forward could use this and cut down on the heuristics and reallocations and copying happening behind the scene. But the idea is that you push in the size at the end, at the beginning of a new frame, and then if the size is different, the GL stack will go and reallocate at that point. And that way the application is in control. When the application decides to render the window at this specific size, it can tell GL, this is what I expect, this is the size I'm going to render at.
Oh, so we could have a GL window size extension, right?
Yeah.
And then we'd use that instead of the viewport information if you didn't provide it.
So what that extension would give you is potentially avoiding a copy for multi-viewport applications immediately after a resize.
Right. Yeah, and most applications do set up the viewport, so you're right, it wouldn't be a big deal. The other thing is that
really low.
it is necessary for Wayland because the size of the window is essentially the buffer that we end up pushing to Wayland. So that it's important that we set the right size for that buffer and not some kind of estimate.
Yeah, and for X it just doesn't matter. We have a separate window size. But so it might be nice to offer that to applications that had multiple viewports. Right? Yeah, exactly. Meh. Yeah. Okay. I'd like to wrap it up now. I know there's lots more stuff. I want people to think about this, and we'll put up a discussion on the mailing list and try to get some feedback and try to come up with a closure on a design in the next while, and then try to do a sample and see if it works. Thanks for your time, and we'll move on with your regularly scheduled activities, which I believe is mostly drinking beer, right, Egbert?
Yeah, and the board meeting. So, thank you, Keith and Eric, for your thoughts on DRI3. There is one request I would like to make. All those who have slides, maybe email them to me, then we can put them up on the wiki page. Now, since we have them on the video, it's still sometimes easier to just look at the slides when you have them on the wiki.